Hi all, this is Sangeeta from VSB Engineering College, Karur. This lecture series is about prefabricated structures and in today's session we will be seeing Unit 2 of prefabricated structures, that is prefabricated components and systems. The syllabus includes behavior and types of structural components, roof and floor slabs, wall panels, shear walls, beams, columns, skeletal system, portal frame system, large panel system and block system. And the figure shows the anatomy of construction, that is from elements to ecosystem. One-dimensional line elements, which is called as columns and beams, and two-dimensional planar elements, which is called as slabs, wall panels and shear walls, and 3D volumetric elements called block systems, and emergent systems, that is skeletal and large panel systems. Structural stability is not inherent to a single piece. It is the calculated result of the coordinated assembly. So prefabrication techniques is entirely deals with the coordination of the different components which are manufactured in different site and assembled at the site where it is required. And one-dimensional elements, columns, the gravity conduits. The force flow diagram is shown in the figure, and buckling mode is shown in the discontinuous red lines, and the axial load is applied in the direction shown in orange color. And the core behavior is pure axial compression, and it may be susceptible to lateral buckling based on the slenderness ratio. And the precast, there may be variations such as single story, straight shaft for continuous vertical loads, multi-story with corbels, features integrated protruding brackets to provide instant sealing for intersecting beams, spliced columns, segmented columns, and multi-stacking with joints. One-dimensional elements, beams, that is the horizontal load transfer, and the blue line shows the bending moment diagram, and the structural cross sections are rectangular beams, and it is standard utility and easy to catch, used for shortest beams. uh, L beams, which is called as spandrel beams, featured for a monolithic ledge on one side, used at the perimeter to support floor slabs without protruding below the ceiling line. And inverted T-beam features ledge on both the sides, used to support floor slabs, minimizing structural connections. Next one is two-dimensional elements. As we have seen earlier, the two-dimensional elements are roof and floor slabs and wall panels. The horizontal diaphragms, floor slabs. There are two different, many types of there. Here in this session, we will be seeing now hollow core slab. It is designed for heavy dynamic live loads. Voids reduce jet weight without sacrifice the bending stiffness. Deflection is strictly limited to prevent floor bounce. So as you can see in the figure, it has a circular void at the center. And the next one is roof slabs. That is environmental load. Double T, designed for massive clear plants. In warehouses, dominant loads are snow, wind accumulation, higher acceptable deflection limit is allowed. The difference between the two components in here is termed as webs. And the next 2D element is wall planners, and they are used for enclosures and also as supports. Some of the wall panels are load-bearing walls, and some may be non-load-bearing walls. Load-bearing walls actively carry gravity loads from floor or roofs down to the foundation. It acts simultaneously as a column, that is compression load can transfer, and a wall. And the types of load bearing walls are solid concrete insulated sandwich panels. The non-load-bearing walls functions are of architectural envelope and environmental barrier, carries only its own dead weight and will not carry any other additional load. It must be designed to flex independent in-building frame to accommodate uh, thermal expansion, and the types are architectural precast and curtain walls. And the next one is the shear walls of the lateral resistors and resist wind and seismic forces. It is extremely rigid along their length. They prevent the building from racking and twisting under lateral twist, and due to cantilever action behavior, mathematically, like a giant wheel vertical cantilever beam fixed at the foundation. As you can see, it is fixed at the foundation and free at the other end. And the placement strategy is it must be symmetrically distributed in the building footprint to prevent torsional forces, that is overturning moment here and base shear, and the wind and seismic forces will be acting on this direction. And next one is the assembly threshold, that is how a components becomes systems. It is one dimensional column, one dimensional beam, and two dimensional floor slab is connected together with the modular coordination and assembly, and they are assembled in a system with the help of joints and connections, and how the loads are transferred here. So first one is floating components and second one is convergence, that is modular coordination, and the third step is the assembled system. Yeah, prefabricated system is defined entirely by how its components are connected in transition from independent parts to a stable cohesive whole, relies on modular coordination and joint rigidity. We now examine the four prefabricated components. The first one is skeletal systems. The system characteristics consist of primarily columns and beams, that is, it is one dimensional forming a rectilinear grid. The behavior, it relies on grid or semi-grid nodal protections to transfer loads, often requires shear walls or cross-bracing or lateral stability, and its application is commercial buildings, high rises, parkings, and highly flexible floor plans where large room space is required, and distributed floor load by the action of gravity, and a beam transfers the horizontal load path, and a column which takes out the vertical load path. So this is the first system, and the next one is a portal frame system. The image shows you clearly how a portal frame system will be, and it consists of a rigid joint, the system's defining feature. The knee joint must transfer massive bending moment to prevent the frame from splaying outwards under roof loads. And the span capacity ideal for vast column-free interior spaces. And the ideal usage, that is more, it is used in industrial warehouses, aircraft hangars, athletic arenas, and agricultural buildings. And the next system is large panel systems, which is of three types: cross wall system, longitudinal wall system, and two-way system. In the cross wall system, floor slabs span between internal structural partitions, that is common in hotels and apartments. Front and back exterior facades are entirely on non-load bearing. And next one is longitudinal wall system. Floor slabs span horizontally between exterior front and rear load bearing walls. And the next one is the two-way system. The slabs are supported by wall panels, creating a box-like cellular structure is exceptionally resist to seismic events. And the last system is block system, or otherwise called as volumetric system. 3D fabrication. Block means the complete rooms or buildings generating sections, that is including MEP systems manufactured entirely offsite in a factory setting. And structural behavior. Each block must be structurally sufficient for transportation and crane lifting, and then mechanically tiled to adjacent blocks to form a unified building mass. And the advantage of the block and volumetric system is maximum parallel works can be carried out, and site foundation and factory room preparation happen simultaneously, drastically reduces the project timelines. And the behavioral contrast between frame flexibility and panel rigidity. Skeletal system deflection due to wind load is shown in this figure, and the large panel system deflection due to wind load is shown in the figure. Frames are inherently flexible, that is, they require moment resisting joints or external bracing to manage lateral deflection, whereas in case of large panel deflection, cellular panel structures are inherently resist, and they absorb lateral forces directly in the in-plane shear capacity of the component. And system selection matrix. The system type is skeletal, portal frame, large panel block, as we have discussed in the previous slides. And the primary components here are columns, beams, and here pitched beams, columns, and here wall panels and slabs. And the last one is 3D modules, and how the load transfer mechanism is happening for these systems, as we have seen in the previous slides, are listed out in the table form here. Point loads are transferred through nodes and joints, and moment transferred through rigid knee joints, and distributed linear loads through planar edges, and stacked interconnected volumetric load bearing. So the ideal applications of each system is it is used in commercial office grids and multi-story parking, and portal frame is used in industrial warehouses, wide span arenas, and large panel is used in high density residential hotels and dormitories, and block volumetric type system is used in rapid deployment housing and modular construction. So the structural stability, which is the emergent property in the prefabricated components, and the prefabrication requires understanding that components behave differently in isolation than they do in assembly. Slabs, walls, beams, and columns are merely vocabulary. It is the syntax of their connections, the skeletal grids, the rigid portal frames, and stacked bolts that generates the ultimate structural stability. So this is the overview of the unit 2, and we will be discussing about the unit 3 topics in the upcoming series sessions. Thank you.